Okay. '28 says a Nash equilibrium occurs when A, each player takes the best possible action given the other player's action. B, you cooperate until the other player cheats and then you cheat forever. C, there is a clear strategy for each player independent of the other player's actions. And D, each player complies with the collusive agreement. Or E, none of the above. And so this is kind of a theory in game theory, the idea of Nash equilibrium, and it refers to a situation in which you have multiple players that you might see in, for example, an oligopoly, and each firm is going to have certain strategies they can take, and those strategies are going to affect the payoffs that that each firm is going to see when we are dealing with Nash equilibrium. So I think this is best observed if we look at a prisoner's dilemma payoff matrix. So why don't we take a look at that really quickly? And so, right, so this is something that we refer to as the prisoner's dilemma. And so if we can put that on the right here. So right, so this is prisoner's dilemma, right? So I think this is the best. I'm going to give some background for game theory and Nash equilibrium in case this is your first introduction to this topic. And so that way it'll be easy to see what the right answer here is here, right? So prisoner's dilemma says, you and a friend commit a crime and you both get arrested for it. And so you're put into separate interrogation rooms and you're both given a choice to either cooperate with the this is a weird way to phrase it. Right. So let's say you're given a choice to either cooperate with the police, and you can basically tattle on your friend who also committed the crime with you, and you say exactly what you guys did, and so that's one thing you can do. Or you can defect, and what defect means is that you basically refuse to say anything, you don't cooperate with the police, and you hope that your friend did not cooperate with the police, right? And so the question here is your outcome is going to depend on what your partner also decides to do, right? So let's say you decide to cooperate with the police and you want to spill the beans, and then the other your friend also decides they want to cooperate with the police. What's going to happen is that in this hypothetical scenario, you both get sentenced to 3 years in jail. Okay. Now, let's say you decide to cooperate, but your friend decides to stay silent, so you basically tattle on them and they say nothing. So they're going to take the full blame for the crime, and you get 0 years in jail, and they get 5 years in jail. And then, so the same happens for you. So let's say you decide you don't want to tattle, you want to stay quiet, and they decide to tattle. Then you get 5 years in jail, and your partner gets 0 years in jail. And finally, if you both decide to stay quiet, then you have you both decide to stay quiet, nobody says anything, and then you both get sentenced to just 1 year in jail. And so that is going to be the kind of general kind of the setup for why you would see Nash equilibrium occurring. And so I'm trying to find maybe a little bit better of a answer. So right. So I think this question actually incorrectly identifies Nash equilibrium as here rather than here. I think maybe we just have a different hypothetical scenario. So let me bring up this one right here. Right, so this is going to be a better kind of depiction of the scenario we're talking about. And so what we see here is, again, you can confess or lie. You both confess, you get 8 years. If you lie, and if you confess and they lie, You get 0 years and they get 10 years. If you lie and they confess, you get 10 years. If you both lie, you both only get 1 year, right? So the best strategy here, right, for you guys the best outcome, if you could coordinate, is for you both to lie and you both get 1 year in jail, right? Because that would reduce how much what you were likely to do, given the other person's choice, right? So what Nash Equilibrium tells us, however, is that the actual outcome is going to be -8, -8, and that is a Nash equilibrium for this scenario. And the way we can look at this is if we break it down into kind of different decisions. So let's say we're prisoner 1, right? So let's assume that the other person is going to confess, right? What would we prefer to do if we knew that the other person was going to confess, right? So we would choose to between confessing, which would give us 8 years in jail, or lying, which would give us 10 years in jail. So obviously, we'd rather spend 8 years in jail than 10 years in jail. So if we knew that the other person was going to confess, we would also choose to confess, right? Okay. Now, let's say we knew that the other person was going to lie, right? What would we do? So we could either confess or lie. Confessing would give us 0 years in jail, and lying would give us 1 year in jail. So if we knew that the other person was going to lie, we would also choose to confess. And what that means is that confession is actually a dominant strategy for prisoner 1. Like, regardless of what prisoner 2 does, either if he confesses or if he lies, we would rather confess than lie. And the same goes for prisoner 2. If he knew that we were going to confess, he would choose to confess. If we knew that we were going to lie, he would choose to confess, right? And so both people have a dominant strategy of confession, and therefore, no matter what the other person does, they would choose to confess. And that's why we would see that confession is actually, a mutual confession with 8 years in jail is actually going to be the Nash equilibrium where this game theory problem actually ends up, even if there is a better outcome if we had both coordinated and we had both chosen to lie, right? And so that is the idea of Nash equilibrium. And so basically says, Nash equilibrium occurs if you have a clear strategy that you can take, assuming that the other person does not change their strategy. And so in terms of the answer choices here, it's going to be answer choice C that best kind of explains that relationship. There's a clear strategy for each player, independent of the other player's actions. And so here we see that it's going to be confession is that clear strategy, and that's going to be what Nash equilibrium refers to. So I know this explanation, again, probably kind of took a little bit long, it was a little bit long-winded, but I think understanding prisoner's dilemma, understanding a little bit of game theory is going to make your life a whole lot easier if you're trying to solve questions related to this concept. So let's take a look at the previous tutor's answer. So the previous tutor said the correct answer is C. Nash equilibrium is a concept within game theory where the optimal outcome of a game is where there is no incentive to deviate from their initial strategy. In other words, no players have an incentive to deviate from their chosen strategy after considering an opponent's choice. So yeah, I think that's a good way of putting it. And if you want to understand Nash equilibrium, look up videos or explanations online about game theory and prisoner's dilemma. Did I spell dilemma wrong? Dilemma, oops. But the solution is correct, it is C. So that